So let's continue our introduction to probability and introduce a few important ideas. One of them is that definitions are the whole of mathematics. All else is commentary. So we've introduced several definitions related to probability. Let's introduce them formally. Again, a random experiment is one whose outcome is in practice unpredictable. The sample space is the set of all possible outcomes, and an event is a set of some of the outcomes. So we'll introduce a few more terms. So an event consists of some of the outcomes from the sample space. The remaining outcomes form what we call the complementary event. Note the spelling, that's complement with an E and not with an I. For example, if our experiment is roll a six-sided die and record the outcome, the sample space is the set of all possible outcomes. That would be the numbers from 1 through 6. We could define the event H, roll more than 3, and those would be the outcomes 4, 5, and 6. We also have the complementary event, which is going to be everything else, 1, 2, and 3. So notationally, we can also refer to the complementary event using a superscripted C, so we could also write this as. So suppose we have two events, A and B. Now, both events consist of outcomes from the sample space, but if the two events have no outcomes in common, we say they are mutually exclusive. So, for example, if our experiment again is roll a six-sided die and record the outcome with sample space, we could have the event E, the roll is even, and those consist of the even outcomes. We could also have the event H, the roll is more than 3, and those consist of those outcomes. And the event B, the roll is less than 3, which consists of these outcomes. And notice that the events H and B have no outcomes in common, and so we say the events H and B are mutually exclusive. Now there's an important subtle point to make. So if our experiment is roll a six-sided die and record the outcome, one event is the roll is more than 3, and the second event is the roll is less than 3. These events are mutually exclusive. They have no outcomes in common, but pay attention to small details. There is at least one outcome. The roll is exactly 3, which is not in either event. And so the events are not complementary. And so it's useful to keep in mind that complementary events are mutually exclusive. But mutually exclusive events might not be complementary because together they might omit some outcomes. So you might be under the impression that mathematics consists of a lot of definitions, theorems, and formulas. But in fact, the only things that are important are the definitions. Now, mind you, the others are useful if you hope to finish a problem within a human lifetime. But again, definitions are the whole of mathematics. All else is commentary. So loosely speaking, a theorem describes a relationship between definitions. Somewhat more formally, it's something we can deduce using the rules of logic from the definitions. More formally, we don't really need to worry about for this course. So let's try to relate some of our definitions. So suppose A and B are mutually exclusive events. On one trial of our random experiment, A could occur, but this means an outcome in A was a result. And since A and B are mutually exclusive, this outcome can't be in B. So B did not occur. And we could make a similar argument if B occurred. And to summarize, if A and B are mutually exclusive and A occurs on one trial of a random experiment, then B did not occur. Or to paraphrase this as a theorem, mutually exclusive events cannot occur simultaneously. So remember, we had this other idea that two events could be complementary. So if A occurs, then some outcome in A was the result of the random experiment. But if A did not occur, then some other outcome that was not in A occurred. However, all outcomes not in A are in A complement, and so that means A complement occurred. So if we put everything together, if A occurred, A complement did not, and if A did not occur, then A complement did. And this gives us a slightly different theorem. Exactly one of an event or its complement must occur on any trial of a random experiment.